said it was 12:20. I try to send out a text, give you a chance to look at the answers. But if you got the answers next to you to look at, then we can answer the questions. So if you got a computer near you, pull up the blog so you can see the answer key. What's up, man? Look on your computer because I put the answer key. I had my refrigerator went out this morning and something else happened. So I just got a chance to upload the answer. So go to your blog and pull up the answer key for 6A6B, because if you know how to do it, if you understand it, that's less time we could be on the live today. Okay, that's fine. Just go to the I put the answer key on the blog. And much as you like to work, you probably only have a few questions. If you still have some questions, you got my number, Isaiah, and you can just call me. Cool. All right. For the other people, go on the blog, pull up the blog, pull up the answer key, look over it, and then I can answer questions that you may have. Okay. You still a nuggethead, man. Hey, Abby. So again, as we come on, go to your computer, pull up your blog. I have the answer key for the practice test that I gave you. But I try to send out a reminder to give you another 5 minutes, at least 5 minutes. But got a lot of stuff going on at the house, so I am hungry, so I'm gonna be eating while we talking. Good morning. Afternoon. Whatever. Hey, that'll work. So what question do we have for section 6A? I mean, for practice test 6A? That's fine. Just look at the video later. 5, Marie. Gotcha. Seven. You know what? Y'all are funny. I'm not working all these problems. Okay, 7 out of 12. That's still a lot of problems. So we're clearly lost. Now, all right, that's it. We'll look at 5. So remember we did this. We said that was the variance. That represents the variance. So that's basically the variance. This is X, so that's the variance X. So anytime you see variance and you see a ladder, this variable, that means this. Okay, so if you do, so I don't have the text to pull it up. So let's say if you had the variant, it said, I think it was variance of, what was it, X plus, let me see where it's number 5. So if you had the variance of X, Y, you can't do this. You can't say, that's not how it works. Remember, if you're going to solve a problem, don't you have to find the variance, add it up, and take the square root? All right, so if you was doing this, so if they said the variance, so what they're doing, when they said the variance, basically what they're telling you is it's the variance of X plus the variance of Y. Because remember, your variance means that you're going to square something. So if you square it, it has to be positive. Remember we did in class, we did that. So another way you can see something like this. That simply means the variance of X plus, remember we said you're doing the variance, the standard deviation is not going to change. So if you're doing plus or minus, it means the exact same thing. That's all 5 is showing you. That you can't do this. That is a no-no. So what you're doing here, you said the variance of X minus Y is equal to the standard deviation of X plus the standard deviation of Y, and you never do that. You always add the variances up. Okay, let's say that I had Z is equal to X plus Y. Oh, we'll do minus. So if I want to find the mean of Z, I would simply just find the mean of X minus the mean of Y. You always do that just the way it is. But if I'm looking for the variance of Z, that has to be the variance of X plus the variance of y. Then if I want to find the standard deviation, it would just simply be the square root of the variance of x plus the variance of y. So if I were to write this in words, if I'm writing this in words, it would just be the variance, because this is the variance of x. This is the variance of y. So if I were to write this in words, it'd be the variance of x minus the variance of y is equal to it would be the variance of x plus the variance of y. That makes sense? So I'm a yes, no, maybe. Like I was telling my honest algebra 2 class this morning. What you mean, nope? This damn, all you doing is this is in word. This is in words, and this is what it look like in symbols. That's it. And then nothing huge. All this means, if I had to write this right here, this would be the variance. Like I said, this would be the variance. This means the exact same thing. This is the equation that you started off with. If you want to find the mean of z, this is what you do. But if you want to find the standard deviation of z, if it's more than one, you have to take the variance of both, then take the square root. They just wrote this in sentences. They just wrote the word variance. We did this in class. When I first showed you how to do that, I said this standard deviation squared is the variance. All right, like I was telling first of our class, I doubt very seriously that we're coming back to school anytime this year. So basically, this is how we're going to be doing for the rest of the semester. All right. So, all right. So the next problem is going to be, and please do social distancing. Stay away from people, because these people out here are silly. I'm not going out of the house for at least the next 3 weeks. I went out last weekend and people all in your face. I'm like, whoa. I mean, you may have something, man. I got to take this home. Okay, now. Okay, so now what we want to do, so let's look at number 7. All right, so number 7. Okay, so if you look at number 7, hold on, let me look at number 7 real quick. I have to pull it up. Give me just a second. Oh, so for number 7, just this. Okay, for number 7, you look at number 7. Anytime you have a geometric distribution, because remember, your first one is really easy. You either have a success or you're going to have a failure, right? All right, now 2. So they told us the probability was going to be, if you look for all red cards, it's going to be 0.5. So each trial, or each time you pick, each trial has the same 50.5% chance of occurring. Supposedly. Okay, now, so independent, back to Marie, for independence, we can use the 10% condition rule. All right, and so what that tell us that what was the sample size? Okay, so we have, so they picked 40, right? Remember, so we have, so they told us we have 40. All right, so if you're picking from 40, so in 10% condition rule said it has to be at least what? At least 400. So n is has to be 10 times 40, which is n is greater than or equal to 400. Now, for the fourth rule, oh, sorry, it should be binomial for C. Let me look. It's binomial distribution. All right, then we have a fixed number, 40. So we know failure success is going to happen. Each trial is occurring, it's going to be, so when you did the, okay, you can't see me, I'm sorry. All right, so if you read the problem, they told you that each trial was 50%, and they did it with replacement. So if they do it with replacement, that means that your probability is going to always stay the same because you're shuffling, you pull out one, then you put it back in there, do a shuffle real good, pull it out again. Okay, so since it's with replacement, the probability is going to always stay the same. And it's a fixed number because they only did 40. Then your independent rule that if you are pulling these cards at a casino, it's going to be at least 400. They're going to pull at least 400 cards. Eight, that's not a problem. So these 4 rules for binomial distribution is being met. Now, it says that until the first success, that would be geometric distribution. But they gave a fixed number of 40. Yeah, I can do 8. That's not a problem, Victoria. But does 7 make sense? All right. So when you do, the problem we're going to be doing now, we do binomial distribution. If you can show that these 4 rules are being met, then it's always about binomial distribution. Only difference between geometric, this will be until you get your first success, until your very first success. All right. So now let's look at number 8. All right. All right. So if you're doing number 8 again, remember this is your population. All right. And so that comes from a large college. All right. And so they told you that your sample size is equal to 10. So we know the 10% condition rule is being met. So from now on, we could, so 10% condition rule. So that means n is greater than or equal to 10 times n, right? So in this case, we know for the large college, you know you have more than 100 students walking on campus. All right. So so independence is met. All right. And then you have, this is your fixed number. All right. So we got 1. So there's 1, 2. And they picked them randomly. And so we got so this is one of the rules. This is the second rule. Okay, the third rule, we have a success or a failure, right? Okay, the only thing we have now for fourth rule is to make sure that all the probabilities are the same. So I think did they pick them randomly? Yep. So since they picked them randomly, each trial should have the same outcome. Should have the same outcome at first. In other words, to start with. Okay, so now we know that's true. We know we have a binomial distribution. All right, so now to find your expected mean for binomial distribution, we have n times p. Then to find the standard deviation, that's just going to be the square root of n times p times 1 minus p. So we know that n is 10. And p, probability of success. What was the probability of success was what? I think it was what, 0.2? All right, so then that would give us, no, it's 0.8, my bad. No, it was 0.2. All right. Okay, so 10 times 0.2, and then that would give us what? Expected mean is equal to just 2. Then here, standard deviation is equal to, so n times p is just 2. Then the complement of 0.2 is 0.8. And so now we have, what is that? 1.16. And that's going to give us 1.265. That's number 8. Don't want to leave nothing out. Okay, so when they actually define, the expected mean, the expected standard deviation. So you got to check see if it's binomial or check see if it's geometric. You're welcome anytime. All right, so the next problem is number 11. So number 11, they told it has a so our sample size is population in this case is 1,171,000. What's that? 460 students. They took that. What was this? SAT, I think. Yeah, ACT. I'm sorry. All right, so they told us that it has a norm distribution. So we know this is the mean, this is the standard deviation, population standard deviation, population mean. All right, so then they told us that the sample mean was what? For each was what, 20, average was 20. Oh, so we had 2 students that took the test. And so basically said, what's the difference between the two? Because on average, so that means both, you got X1, so that's going to be student 1. Then X2 is going to be student 2. So what they're saying is, as a student come up, the average score for student number 1, we don't know their score, so we're going to say the average score is for the first person, it's going to be what was it, 20.9, and the standard deviation was 4.8. All right, so student 1 on average is going to score 20.9. Student 2 is going to score the same thing, because we don't have their scores. We just try to predict what their scores would be. So it asks you what was the difference. So basically, you're going to do capital Y is equal to X1 plus X2. Oh, we found the difference, right? We're doing the difference of the two. So we're trying to see what the difference would be. All right, so that's the equation you were right for that. So now, if I want to find the mean of the scores, mean of Y, so I'm simply going to do, since I'm doing the average of the two, I'm going to do 20.9 minus, it's kind of like the insurance problem we did. Everybody going to have, so on average, it should be the same. So we know we take the difference of these two, it's just simply going to be 0. So this is basically a transformation of your mean and standard deviation. Now, so you want to find the standard deviation of the two. So now we're going to do the variance of Y, the combination of the two together. So that means we got to find the variance of X1 plus the variance of X2. So basically what we're going to do is we want to find the standard deviation. That's the square root of 20, standard deviation is 4.8. So that'll be 4.8 squared, 4.8 squared. And then when we do the standard deviation for that, we should get approximately 6.7882. All right, now that we have this done, now we could go back and say what was, so the B part asks us, what's the C part? The C part asks us what's greater than, what's less. What's the difference between the two? The difference is greater than 6. So I want you to look at this. I want you to write this down because I got to erase this. Okay, so the transformation is going to be, I'm going to put the mean norm for Y is going to be 0 and 6.7882. But this how you find in the beginning. This how you do your transformation. Because this is based on two of them. Not two, I'm sorry. This is based on one individual. But then they ask us to find the difference between individuals on average. So we got to take the difference, then we got to find the standard deviation for two. So we just did a transformation of the data. So now they ask us to find the probability where y is going to be greater than 6. So go ahead and write that down, and then so I can keep it moving. So we know since it's a norm curve, norm distribution, we can use the z-score form. Now, they say that the difference of the two was greater than 6. Okay, for example, before I work the problem out so that makes sense to you. All right, so let's say person number 1, so it says student number 1 made a a 21. We still talk about the ACT. All right. So student 2 to do so student 2 is score is greater than is at least is score student 2 score is more than 6 in the positive, more than 6 above. So that person needs to make a 27 or higher, right? That's the person that's doing better, 6 greater than student 1. Now we're gonna go back second scenario. Student 2 score is less than 6. Oh no. Okay. Less than 6 below. So that person has to make a what? What? 14 or lower. So that's why you got to look at both sides of the equation. So it just said greater than 6, but you got to do greater if it's above, greater than above what the 6 more than this score this particular student did. Student 1. So student 2 should do 6 more than, so they made a 27 or higher. So, but if the student 2 did less than more than 6 in the negative direction, so that person had to made a 14 or less. So that's why it's a two-sided question. So now with that example, we're going to go ahead and I'm going to show you how I came up with the solution that I did that I put on your answer key. All right, now, so I hope this kind of makes sense. All right, now, so what you want to do here, you want to come here, you want to do the probability that your y is going to be less than -6, or we're going to do the probability that y is going to be greater than 6. All right, so what we want to do here, we're going to change this to the probability z is less than -6. That means more, the difference is more than -6. Then we got to do or the probability that z is greater than 6. So when we do the math, oh, I'm sorry. All right, -6 minus 0 all over 6.7882. Or the probability that z is more than 6 minus 0, because we talk about the difference. Because remember, y is x1 minus x2. All right, so now we have 6.7882. All right, so when we do this, we should get z is going to be less than a negative, and the answer should be the same. So this is just 0.88. This is above 0.88. And then, so if we were to do the curve, all right, so 0.88 would be, I want to say about right here. And then a negative 0.888 is about right here. All right, so if we look this up, they should be equal to, it should be the same, shouldn't it? All right, so we should get, this should be 0.1894. This also should be 0.1894. Then if we want to find the total, the area combined, we're just going to do 2 times 0.1894, and that will give us 0.3788. All right, make sense? I haven't heard nothing from nobody in a while. All right. All right, so let's look at 9. Hold on for a second. Okay, so for problem number 9, you're just asking you, do you know the rules? Okay, so your starting point for your geometric distribution, you do not count until you get your first success. So let me erase this. So write this nice and bold. So if you have a binomial distribution, it starts from 1 to n. Because geometric doesn't count until you get a success. Binomial, you can start off with a failure. That's number 9. All right, so we're going to mark that off. And then we'll look at 10. Oops. All right, so we're going to go ahead and start number 10. And so number 10 actually define. So basically what you're doing for number 10, you take your chart and the information that's given to you. So you have your outcome. You have your probability assigned to that outcome. So we got 1, we have what, what's that, 0.5. Then we have 2, which is going to be 0.3. We have 3, which is going to be 0.1. And we have 4, which is going to be 0.1. So we know this is a probability model because this is 0.8, 0.9, 0.1. All the probabilities between 0 and 1, and the sum of the probabilities equals to 1. So we know we have a probability model. Now, so to find the expected mean, because we don't know if this is binomial or not, so we got to go back to our basic formula. All right, so that's going to be what? 1 outcome times the probability assigned to the outcome. Okay, that 2 times the probability assigned to that outcome. Then we got 3 times the probability assigned to that outcome. And we have the last outcome times the probability assigned to it. So that's going to give us 0.5. This is going to give us 0.6. This is going to give us what? 0.3. And this is going to give us 0.4. So the expected mean, that's just the sum of it. And so that should give us what, 1.8? All right, now to find the all right, so for this problem, this is your mean. So we know the mean is on average. So this is the average amount of DVDs that people are going to purchase from the machine. Per visit. Now, so if we look at the standard deviation, all right, so to find that standard deviation, we're basically going to do, we got to do the So that's the okay. So we're gonna do here. We're going to do what? We got to do the outcome minus the average. The expected means, which is 1.8. Square that times the probability assigned to it. Okay, and that should give us what? 0.320. Then we're gonna do what? To the outcome minus the average outcome squared times the probability assigned to it. Then that should give us 0.012. Then we're gonna do 3, the outcome minus the average outcome times the probability assigned to it. And so then that should give us 0.144. Then lastly, we're going to do 1.8, the outcome minus the average outcome times this probability of occurring. So that should give us 0.484. And then add that up. Let's give us 0.96. Where is it? What's that 0.96? Okay, so that's going to be 4. All right, now that's the variance. Now to find the standard deviation, we have to take the square root of this. And that's 10. Now we can round this for a decimal place if you like. Is everybody gone? Nobody's answering. I hope you're getting this. Mm-hmm. All right, so that's 10. Now I put on the blog how to interpret this because this is standard deviation. So the average amount of DVDs is going to be purchased per visit is 1.8, and then the variance from the mean of the purchase is about 0.98. Hey, look, don't worry about my food, man. That's my leftover for later when I'm hungry. Can't be starving. But thank you though. All right, so I'm going to go ahead and erase this. And on the blog, the explanation, I just want to show you how to find the answer. On the blog, the explanation is on there. All right, so let's keep this moving. And please be safe out there. I do not want to hear about any of my students catching the virus. And definitely don't want nothing to happen bad to you. All right, now, so let's look at number 12. Oh, okay, so number 12. Now, the problem number 12, you can do it several ways. You could do a geometric or you could do binomial. It depends on how they ask the question. All right. So some of you will probably want to know how to do 12 because of the question. And so they tell us in the very beginning that we have the probability of success for each trial is 0.84. All right. And we know that X, the outcome we're looking for, is the professional soccer. Okay. All right. Now, so we know we got a success or failure. It's going to be independent because you play professional soccer, kick the ball thousands of times. So success or failure, independence, same probability of success. That's 3. Now the only thing is when they ask you a question, is it a fixed number or you doing it till you get a success? Okay, that is the question. Now, so let's look at A. So A said A part tell you until first success. So when you see that until first success, you automatically know that it's going to be geometric. Well, geometric distribution. All right. So they want us to find what the probability is going to take exactly 5 to fail. So we know that P is your success, which is 0.84. They're trying to trick us because we know that 1 minus P, that's going to be your failure, right? Which is going to be equivalent to 0.16. Now, the problem asks us what's going to be the probability of your first failure is going to be the 5th. Let me put this in words. All right, so that means this now, your failure now becomes your success. They're trying to trick us, but we got this. Okay, so now we're going to do the probability of X is equal to 5. So your success is going to be 0.16. So that means 0.84 is going to be your failure because your failure is your success. So then we'll put 4, and now that 5th try, we got our failure. So remember, these two numbers, your bases added up equals 1. Oops, excuse me. Your bases add up to equal 1. Your exponents has equal to what you're looking for. So now when you do that, so this is your success. Because in this case, your failure is a success. And this is your failure. And if I mess this up one more time. All right. So now, so we do that, we should get excuse me. Oh, no. What am I doing? I'm looking at the wrong problem. All right. So that should give us 0.0797. So that's going to be your A part. And we know it's geometric because they say your first success. But in this case, your failure is your success. Oh, we can go back to 10C, but let me finish this up there and we'll do 10C. That's not a problem. That is not a problem. Okay, now, so let me go back. Let me finish this up. Then we'll go back to it. Okay, now, so we do B. So B, they give us a fixed number. So B, we have a fixed number. Which is 10. And they want us to find the probability that is less than or equal to 5. So you got to do your cumulative for this one. So for this one, that's going to be, you could do your, it's binomial since it's fixed. So you can do your, well, if you was taking an AP exam in college, they want you to see what you're talking about. So binomial starts at 0, right? So 0 plus ... plus the probability of X is equal to 5. All right. And then you can use, don't write the binomial distribution on here. Because if you do, you got to explain what it means. So we're going to do the CDF, because that's cumulative. That's all this added up. And then your sample size was 10. Then your probability was 0.84. And then your lower bound is 0. Your upper bound is 5. Then when you do that, you should get 0.0113. So this is your lower bound. And this should be your upper bound. And when you put in your calculator, graphic your Inspire or your TI-84, it's going to ask for this. And then it's basically, it's calculated to find your probability, all 6 of these individual probabilities, and add them up. Now, if you take an AP exam, they know that's going to take you some time to try to do all of them at one time. So just write this to let them know that you know what you're talking about. You know how to set it up, because that's the most important thing. Oh, so the C part, before you freak out, I'm not going to do it. Okay. Just look at the example. And because we got one more practice test to do, then I'll answer them. But I want to get this done because I know you have a bunch of questions on the second test, and I don't want to be all day because I have to teach my review test. All right. So I'm going to go back to 10. 10C for old Thelma. All right. And sorry about that. Okay, so when we did, so 10C, well, we know before we, so 10C, but we know that when we found out the expected mean was 1.8, we found out the standard deviation was, what was it? Standard deviation was 0.98. All right. So the transformation, they told us that P is equal to 0.75x minus 0.2 or 0.05. 0.05, get my problems mixed up. So now, if I want to find the mean of this transformation, I'm just going to do 0.75 times the mean of x minus 0.05. So that's 0.75 times the mean of x is 1.8 minus 0.05, and that's your math for that. Now, to find your standard deviation for P, since this is a constant, we're not going to use it. So all you have to do is basically do 0.75 times the standard deviation of x, which is just going to be 0.75 times 0.98. Then that'll give you an answer for that. So that's 10C. And we did 12, right? Yep. We have done 12. Okay, good, 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 good. All right. So while you're looking at this, we need to start doing 6B. So we can get on out of here. All right. My refrigerator went down, so got about 200 something dollars worth of grocery in the refrigerator. So we got to go buy a deep freezer. Hope I can find one. Oh, 7. I got you. As for 9, it's just A. 9 is A. It's not cut off, it's just A. Thank you, Danielle. All right, that's it. Just A. That's all you need. I mean, number 7. We only got 3 more problems to do. That's a good day. Outstanding. Go ahead and do these 3 so I can get out of here. Oh, number C. Number 2. All right. So remember, these are your probabilities, right? All we need is this part. So we know the probabilities, they all have to be between 0 and 1, and you sum it up, it has to equal to 1. So we got 3c plus 2c plus 0.4 plus 0.1. All this have to equal to 1. Because your sum of it probably has equal to 1. So now what we're going to do, we have 5c is equal to plus 0.5 equals to 1. We're simply going to subtract. So that's 5c equals 0.5. So c equals to 0.1. Now, if we go back in here, 3 times 0.1 is 0.3. This is 0.2. So 0.3 plus 0.2 plus 0.4 plus 0.1 equals to 1. So therefore, C is just equal to 10%. That's it. It just, this problem is to see, do you know the definition of a probability model? All the probabilities have to be between 0 and 1, and the sum of all the probabilities have to equal to 1. Pretty simple, I know. Why didn't I even ask them that question? I feel so silly. I know, I get it. All right, now, all right, so that's how you do number 2. All right, let's look at number 7. Oh, for number 7, in order for, remember you got your rule, you have all the probabilities have to be the same in each trial in the very beginning, right? So if you look at that particular problem, you picking something, but there's no replacement. So if there's no replacement, as you pick it, the probability constantly changes. So that's why it's neither geometric or binomial. Because you look at the last practice, the practice test A, we did a problem that it was said they did with replacement, where they were picking cards out of a deck. They picked the card, replaced it, and then shuffled it well. In other words, make it random. Okay, so neither one of these explanations had a replacement in it. So that means that the probability is going to change each time that you draw a card. Or each time, I think it was drawing a card for that problem. The probability is going to change each time. So that means your initial probability is not going to be the same for each time you do it. All right. So now let's look at number 8. All right. So number 8, so we got a success or a failure. Always success or failure. That's the easy one, because you're either going to succeed or you're going to fail. All right. Now number 2. They have a fixed number, which is a fixed number in this particular case is 18. All right. Then they also tell us, okay, for independence, we can use the 10% condition rule. Which is simply your population is greater than, has to be at least greater than, it has to be at least 10 times your sample size. Or you can say 1/10 of your population. N can be no more than 1/10 of your population, which N we know is your sample size. All right, then 4, the last thing we need to do is the independent. Okay, so we got independent. Oh, same probability of occurrence. Each trial has the same probability of occurring in the beginning. That's it. So all these, so we got success or failure. They told the fixed number was 8. We know it's independent. And now each try, they told us the probability was equal to what? What was that? 0.9, which is your success. And then they asked us find the expected mean, expected standard deviation. All right. So we know that the expected mean for, so this is binomial. All right, so we want to find the expected mean. That's simply just going to be n times p. And so n is your sample size. So that's going to be, what, 18 times 0.9. And that should give us 16.2. Now we got to find the expected standard deviation, which is going to be the square root of n times p times the failure. M1 minus p. All right. So now, find the standard deviation of that. We simply just going to do, we know n times p is 16.2. And we know that if the success is 0.9, that means the failure is 0.1. So we should get approximately 1.2728. Oh, all right, is that it? We're done. So I have to, well, I guess I can do it now. As soon as I'm done with you all, I'm gonna go ahead and put a third practice test, and that'll be for tonight. And then I will give you, we'll do a quiz tomorrow in the beginning. Well, we'll do a quiz tonight, then I'll grade it, and then we'll go over it tomorrow. Then I'll give you the test after we go over the third practice test. I get a test tomorrow night, tomorrow afternoon to finish. So yeah, we need a quiz. I need to know what you know. All right, so if that's it, we're done. So I'm gonna go, when I'm done, I'm gonna go ahead and just upload the practice test to go and get it out of the way. And I know you got to go to Dr. Davis in a little bit. All right, bye. All right, see you all later if you don't have any questions. All right, I'm gonna go ahead and upload that as soon as I get off here. Yes, Danielle. Yeah, we'll get it. I'll send the quiz this afternoon. I just want to download the test because I have to get ready for my for the AP review, which I better see you in. All right, see you later.